Hey everyone, welcome back to the shop. Probably a little different video format than what you typically are used to seeing from me, especially to start out with. Thought I would just show you kind of how my typical day starts here at the shop. I usually try to get here by about 6:30 every morning, just because I wake up early now. I guess that's what you do as you get older. Your body just wants to wake up early and get moving. The other benefit of that is beating all the traffic, later in the morning. But I wanted to show you how my mornings have been started since we got our new VM up and running. We've got our new Tool-X vises machines ready for our production. They are working exactly as engineered and designed to. Our jaws are working exactly as they were intended to, as we machined them to hold our work pieces. And everything is running great over here on the VM for our drill index. And I wanted to touch base on that in this video. I think this is going to be another mixed format video, a Saturday night special, if you will, that might have a few different things in it, some stuff that we've been doing. I've got some vertical videos that we've taken this week of some other stuff going on. I think we'd like to show that in today's video. But really, I just wanted to kind of go over like where we are in our production for our first A-bomb part there that we have been making and putting out there on the website for people to purchase. And talk about the improvements from going for this production, for this particular part, moving from the TRM 3016 mill over to our VM 3018, and how things have improved. The additions, the upgrades that this machine has over the TRM, and how they've improved our workflow, and how they are improving the overall cycle time of the parts that we're machining here. It's been a wonderful journey the past 3 years, learning CNC machining and manufacturing, and learning how to operate these Milltronics machines. And I absolutely love it. I really do enjoy it. I love the complexity at which they handle jobs. And I know that a lot of what I'm learning to do is still very basic in the CNC world. 3-axis machining is as far as I've gotten, but being able to use these machines to quickly and efficiently machine complex parts is simply amazing when you compare it to the older ways in which we have, that I've always done things, and the way that I've learned to do things. And traditionally, the way that I've shown things on this channel over the last 13 and a half years, I believe it is now. I've been enjoying sharing the evolution of my experience as a job shopper, manual machinist, who's traditionally always done repair work, fix things, make one-offs, make onesie-twosie parts, work on hydraulic cylinders, build gearbox shafts, all the things that an industrial general machinist has had to do in their career. I have really enjoyed taking all of those fundamental skills that I've learned as a machinist and tried to apply them to modern manufacturing. Every time I do a job over on these machines, it helps me that much more. Every time I understand just a little bit more about what it is that I'm trying to do out here on these machines. All of the training I've done using to use Fusion, Autodesk Fusion, the CAD software, I understand it a little bit more. Each time I get on there and I train and I practice and I'm taught, I learn a little bit more and I improve a little bit better. There's been plenty of days where it's been a struggle and I get frustrated. But whenever I push through those struggles and I accomplish my goal and I actually create a part that I'm trying to create, it's very rewarding and fulfilling. And I certainly appreciate everyone that's continuing to follow the journey. We've had people that's been following me since the very first year I ever started making YouTube videos, and things have changed over the years dramatically. I think things have improved as far as the quality of work that I do anyway, you know, what I can do. And I'm just enjoying continuing to share that journey with everyone. Whoever decides to follow along and join us with what it is that we like to share here on the channel. So again, I wanted to talk about our production. I'm going to talk about things that I have learned in the machine here going on this job. This is our first official job in the VM, is our drill index. You know, we machined our Tool-X vices and now we're on our production part here. We have made some improvements. We've included some new tools. I want to talk about those. I've got some video to share of that. I made some errors. We're going to talk about some of the errors that I've made and show how we improve that. And whatever else we have to share with you that might make an interesting Saturday night special video for you guys. I'm going to try to share a little bit more of this footage here. And I know it's hard to see. That's one of the downfalls of using CNC machinery. Usually you have to flood everything with coolant. You don't have to, but I would prefer to eliminate any possible problems that would cause by running a cutter dry. So showing this is a little more difficult than trying to get onto a manual mill or lathe. We all know that. But I am going to try to show you a little bit of footage of this. We've got some improvements with our new cutters, and watching it do some roughing over here is an absolute pleasure, watching it sling some chips against these glass windows here. So we'll get to that. Right now it's just cutting the racetrack. That's what I call anyway. I'm going to grab one of these guys right here. Right now it's just cutting this racetrack profile all the way around the part. And then it'll move on to to all the holes. I've got a couple of drills. The small holes, we use individual drills up to 1/8. And from 1/8 to 1/4, I use a 1/8 drill to drill those out. And then from quarter around the 1/2 inch, I use a 1/4 inch drill to drill those out. And then we use a 1/8 end mill and a 1/4 inch end mill to bore those holes to the size. And it does a great job at it. I was also going to mention that this is Thanksgiving week. Abby and I are going to have a short week this week. Today being Tuesday, we're going to take the rest of the week off to spend time with our family, both of our families. So my side of the family and Abby's side of the family. So we're going to have 2 Thanksgivings. Tomorrow I'm tasked with smoking all of our turkeys. So that's what I'm going to do, but that's a hobby that I greatly enjoy doing. I love barbecuing and smoking and creating delicious foods out on the smoker and the grills. You guys can follow a little bit of that action over, we have some other Instagram accounts. A-Bomb Barbecue is the one where I like to share my cooking and barbecue and that kind of stuff. A-Bomb Adventures, a little bit of everything else that we get involved with outside of the shop here. So feel free to check those pages out and give us a follow if you'd like. I'm going to be busy tomorrow smoking our turkeys and visiting with family for the rest of the week and just enjoy a few down days. So a short week for us here, probably for a lot of you guys out there too. And we hope that everybody watching this has had a wonderful Thanksgiving holiday week. So the 1/4 inch drill is running now. It starts at the 1/2 inch hole and works its way around to the 1/4 inch hole. We're on G54 work offset, and it'll shoot over to the G55 work offset. And then when you jump over to the right side, we have 4, 5, 6, 7. So G56 and G57 are over here, which is the bottom. My goal with this setup here, with the new machine, more tool capabilities here. We can hold 24 tools versus 16 over there. So now we can hold every tool that I need with additional pockets available to run this job here without having to manually install any tool changes. So after that 1/4 inch drill, it pulls the 1/16 drill, and it drills the 4 smallest holes using just a drill. Those do not get milled out to size. I love the swing arm tool change. Much faster with production. So anyway, it's going to continue drilling those holes around there. Here's a look at where we're at today. Everything's looking pretty good. We made a modification to our model. I'll show you what we did there in just a minute. We'll talk about that. I've maintained this pattern in the bottom of the drill index. I have always liked it ever since the beginning whenever we saw this, and I think everyone who is a fan of these drill indexes liked the pattern as well. So we decided to leave that in there. We are roughing them out with a 2-inch face mill now, but we finished this floor and the contour passes with a 1/2 inch helical end mill. Same cutter that we have used to cut every single one of these. In fact, all of the cutters that I started with the exception of a 1/16 and a 1/8 end mill, are all the same. Those 2 mills got broken early on before I got all the feed and speeds adjusted to where they needed to be. So all the other cutters have been exactly the same. Just about got this can filled up. This has been a great addition now. In fact, I'm starting to get pretty full. We're going to have to go ahead and clean this out again. So we have our auger system on this that at least, gets the chips out here. I will say that this pan right here that comes factory with the machine, I don't really like the design of this all too well. I think it's a little bulky and heavy. It's made out of steel. I'm going to get with Joe over at the fab shop and see if we can come up with a little better design, something more of a bucket size made out of aluminum that's easier and lighter to pick up and dump it into these cans right here. Right now that's the 1/4 inch end mill, and we use that to interpolate all the holes from 1/4 up to 1/2 inch. It just bores it to the size. And I have worked hard to try to get these holes to a good size, a good middle ground size. It's not too tight, not too loose. So most of the holes we try to shoot for about 4 thou clearance. And what I have found is that with the drills that we have bought and that we supply with these guys, our Chicago Latrobe, a lot of those shanks are measuring like 1 thou undersize. So a lot of these holes give you about 5 thou clearance. When you get down under a 1/4 inch, that reduces down to about 3 thou. And with the 4 smallest holes, we try to give you at least 2 thou clearance with those. And it seems to be working pretty good. You got to try to find a good happy medium where the holes aren't too loose or too tight, Machinists would prefer these to be a much closer fit than what they are, but this needs to be a working piece as well. Something that people, if they choose to, can have this sitting out just like here on the bench next to your mill, next to your lathe, and be able to easily just grab these drills, use them, and drop them back in the hole. So I think we've kind of reached a nice happy medium on our clearance sizes. You can see they wiggle around just a little bit, but Once they're in there, they're standing up proud and they look good. I think we're going to jump from the, let's see, I think we may go to a 1/8 end mill next. 1/8 end mill is up next, but what it will do from here, it's going to machine this pocket, the logo. It's going to machine the pocket out of the logo there. And then once it finishes machining the pocket, it's going to jump over to the remainder. Let me see if we can pull you up on here and show you. So that 1/8 mill will come around here and rough out this pocket. And then it's going to mill out the smaller holes here from a 1/4 inch down to 1/8, the interpolation, the spiral pattern. These are the first two that I machined on Op 2 on the right side vise, and they have some errors in it. I wanted to talk about that and show you what happened there, and then we were able to correct it. So it's only these two that have that damage in there. But I also wanted to point out this color here, this purple, is one that seemed to be really liked across our social media channels whenever we shared this. This is just a sample. Whenever we got our boxes back from our green and our red, which is the two colors that we've been selling, we wanted to have a purple anodized as a sample, and it seemed like we had a really great response from the purple. So this next batch, the ones that I'm working on right now that you see in this video, so we're doing 50 at a time with the anodizers. That's where we're going to be at right now. The size of these parts that we're making, the anodizer can hold a total of 48 of these at one time on a rack and fill the tank up. It's better to go ahead and fill the rack up because they're going to charge you the same amount of money whether you just send them a handful of them or you send them the full 48 for the rack. So we're going to just be shooting for 48, and then we'll have a couple additional ones in there as well that we can use for like color samples. That's what we'll probably do with some of these guys right here. So anyway, we're gonna have some purple done. We sold more red than the green, so it seems to be popular. So I think the next batch we probably have some more red done because we sold out of those. And the other thing that I was going to point out that I'm going to do different this time is the machining that we're doing right now for Op 1 and Op 2 is that I'm eliminating the fractional engraving on the racetrack. We're going to leave that off. We're going to leave our marking on the bottom off as well. And the reason why I'm going to do that is we're going to go ahead and have these guys anodized. You can see there's no numbers on here. No numbers on the bottom, no serial data. Once we get them anodized, I'm going to put them back in the VM, and we're going to go ahead and cut them so that it will really highlight the characters at that point. You'll be able to see them and read them a lot better. I know it's a great look. We've had a lot of people suggest that, so it seems like we have a lot of folks requesting that, and I think that's what I'm going to do. That's what we have decided to do, and hopefully my plan is going to work out good. My main concern is machining the anodized coating. I don't know if that's going to damage the cutter prematurely, if it's going to last for a while. I really don't know what to expect, but we're going to go ahead and give it a shot on this next batch of 48 units and see how the engraving works. This is prototype number 2, and what I'm talking about with the engraving after the color anodizing on there. So we know that this looks really good. It really pops. I did not do that with the fractional characters on here. So that is what we're going to do, hopefully going forward. I hope this turns out to be something that we can just implement into a solid design and just keep it that way. And I personally want to continue engraving them myself. We're going to be looking into investing. There's a tool that you can use in the spindle. It's a speed increaser that uses the through spindle coolant and increases the RPM, allowing you to run a lot faster speed when engraving. So that's something that we're looking into, that we're going to hopefully see if we can implement in our production, and that will greatly increase or let me just say decrease the cycle time required to do all the engraving on the top and the bottom. You can also laser etch this for sure. There's a couple things there. We don't have a laser yet. We'd like to get one. It's just something that we haven't invested in yet. I haven't spent any time researching what laser machine to get. I like the machine look myself. I think that this is a lot nicer looking finish when you machine this versus a laser. Now that's my opinion, and this is the way we're going to do it, is just laser engrave it. In fact, the anodizer, the folks that are helping us anodize this, they offer those laser etching solutions as well. That's a service they provide. So they can do the laser marking, they do laser etching, they do all kind of custom stuff, and they offered to do that for me. And that's something that later with some of these samples, things that are not perfect, that we may send them and say, okay, go ahead and give it a shot. Let's see what it looks like with the laser etching and the laser marking, and we'll compare a laser mark versus a fully machined engraving cycle on our parts there as well. So I wanted to talk about the error that we made on these guys here, and there's two of them because these were the, well, one of these was one of the first two, and then there was another one that's already in the cart over there. What happened is, if you look right here, you'll see there's like a little scallop machined in here, a little divot. Both of these identical, and that's because the additional of we added a 2-inch face mill. So we've got a new Ingersoll 2-inch face mill. They call it the Illuminator, and it's a face mill that they recommended to use. You can use it for roughing or finishing aluminum, and I wanted to use it. I wanted to try it and see how it would work to rough out the bottom, and I'm glad I did, because it's made a big improvement on the overall cycle time. And not only has it improved that, it's just fun to watch. That thing comes in here, and we have a hat on the top when we start op 2, and it cuts the entire 1/4-inch thick hat off in one pass, and then it comes and it pockets this out, and it does it really quick and efficiently. And whenever it makes these cuts, we're running a really, really fast speed, high feed rates, and it's just slinging rooster tail chips right into the glass of the machine. But anyway, what I was getting at was in our op 2, we've got two pieces set up kind of like this right here. Then you have this hat. In the model, whenever we modeled this in Fusion and we added our tool path for the pocket, you have a much larger diameter cutter versus what I was using in the 1/2 inch. And so when it starts this adaptive pocket cycle right here, the cutter starts over here in this position, and I didn't realize that it was actually just touching the first workpiece there. And I missed it on the first one, didn't even see it, loaded it up with 2 more. And then once I finished the second 2, that's when I noticed this divot here in the part, and it was where it was cutting it. So we made an improvement. I got with Kevin at mechanicaladvantage.com. We got together on a session. I talked through our problem, and he helped me adjust my tool paths. We actually created a model on both sides of our pieces right here that would simulate that there's like a fixture here and a fixture here with a certain amount of spacing in between it, so that whenever the cutter would come across here and feed down to start your first cut, it was not, let me just say right here, it wouldn't be hitting this piece when it goes down to start the cuts there. So that was a really great fix. Kevin helped me with that, and I greatly appreciate that, because I was concerned that I wasn't going to figure out how to be able to use that 2-inch face mill to do our roughing on the bottom, but it turned out great. So we made another modification to our part here at the request of the anodizers. So whenever the anodizers hold these, they have these clips, and I got some photos, so we'll show that on screen so you guys can see what we're talking about. But they got these clips that will clip in there and there. That's how they're holding them. So they're holding it in this orientation vertically on these racks, and then they lower the whole rack down into the solution to do the anodizing. And the way that we did our first 100 is the clips basically just stick in here with friction. So there's nothing preventing it from just being pulled off in some way. And there was a couple that were dropped. They said that they did their best to try to be very careful, but you know, you got this big rack that's being held with a crane with all these parts being held on there that's being lowered down. So you're bound to have an issue here or there with something dropping or hitting. Maybe it hits the side of the tank and it comes off. But anyway, there was some issues. We had some damaged ones. So they asked me, can you machine a groove on the inside of these legs that the clips will actually snap into and hold, have a solid bite on? So I said, yes, we can do that. So we ordered a couple of these key seat cutters from Harvey Tool. They do a good job. They have a lot of these different size key seat cutters here. So this one is 1/2 inch diameter, 1/8 wide. And we added this program in there. And again, Kevin, Mechanical Advantage, he helped me adjust the model. And we added these 4 half-moon shaped cuts in there. That looks exactly like a Woodruff key seat, only it's shallow. It only goes 1/16 deep. So we added this tool, and we come in there and we make these 4 cuts very quickly. And this should allow those clips. I went back and forth with some pictures and measurements showing the distance that these are. And the anodizer, you know, he's got his clips and he's measuring it with calipers, and they said that should work great. So now when they get their clips, he says they should be able to stick it in the bottom, hook the bottom, and then push the top. I think they kind of pull the clip down and push the top in, and then let the clip just snap into place. And that should eliminate any risk of these things, you know, shaking, vibrating off when they're being handled and moved around with the crane. They got several tanks that they go in. I can't remember how many, but they have like 4 or 5 tanks that they lower these things down in to complete the entire process for the anodizing. I know the first one is like some kind of cleaning tank, and then they have other chemicals that they have to go through. And for you guys that already have purchased these, if you look in the bottom, you may see 4 little bitty tiny dots down in there. That is where those clips held these during the anodizing process. And they were very upfront about that, and they told me, you're gonna see these, is that okay? Are you okay? You gonna accept that? I said, yep. I mean, we're just gonna go with it. It's on the bottom. You don't typically look at the bottom unless you're just, you know, checking out the part, but you can't really see it. So I made the decision that's gonna be perfectly okay. So anyway, that's an addition that we made to our part using this new key seat cutter from RVing, and it's working well. I think it's doing a good job, and hopefully that's gonna eliminate any issues during the racking process and holding this during anodizing. Working on the chamfer now. We use a 1/2 inch diameter 90-degree chamfer tool. It just does a plunge move on 27 of the holes, and then the last 2 does a 2D contour going around, because, you know, you're 2 large holes versus a 1/2 inch cutter. I just couldn't get a plunge move and get the correct depth of the chamfer that I wanted. Right here. Contour, contour. And that's over. That's finished. What's next? 1/16. This is gonna go in there, and it's gonna finish cleaning up. This 1/16 will come in here and clean up all of these letters and characters, and clean up this outside frame there as well. We're using a 90-degree engraving tool there to engrave. This is like the web link, the abomb79.com. Might be a little hard to see on video. It's just engraving that little logo in it right there. And then once this is finished, we'll be swapping over to Op 2 to finish the bottom. All right, finished with Op 1. We're swapping to our new Ingersoll illuminator. This is where things get a little more exciting. There's the hat gone. Now we're roughing out the inside. So now it's on the second cut there. I've got this set with our depth. It actually takes 3 different steps in there, step downs, to get to the final depth there. This one's really hard to see because of all the coolant. I mean, it really splashes everywhere on this mill, so it's just really hard to get this one on video. But you can hear it. I love that tool path. A little more cleanup to do on those feet. And then we'll swap over to the next one. Here you go. It slings those chips against these glass like it's gravel. Not much better, I know, but a little different angle. So it's doing a good job. Love that cutter. So the difference between this and what we were using is I was using the 1/2-inch diameter chip splitter to come in here and mill the hat off and then mill all this out, pocket it out, where that illuminator has greatly decreased that overall cycle time, and it's getting it done much faster now. So I am leaving I believe I mentioned this earlier, so we're leaving 10 thousandths in the floor here, so we can come in there with our 1/2-inch end mill, and it'll finish the bottom of the feet, this floor here, and this inside profile around the inside of the legs there. I believe it's just about finished with these two. Yep, and then now it's going to grab, so that's a 1/2-inch diameter, 3 flute, 60 thousandth corner radius end mill, and that's going to do all the finishing there on the bottom side. It's taking 10 thou off the bottom of the feet, and then once it gets that, it's going to drop down into the floor, and it's going to start milling this, what looks like a diamond pattern on the bottom of the part there. So what has happened is, you know, moving the production over here to the VM from the TRM is we have a decreased cycle time because of the speeds that we can run now. The TRM will handle, it'll go up to 8,000 RPM. Our VM will go up to 10,000 RPM. So because of that higher RPM, we're now able to cut at a faster rate. The surface speed is increased. And I believe with the Inspire controller running this machine, it's running smoother. This, like right here, we're milling the feet. This profile right here, this curved inside of the feet, and it's just running back and forth across there. It's just running nice and super smooth over here on the VM. But we have been able to decrease our overall cycle time because of the higher RPMs, and the tool paths are working beautifully over here on the VM. So that is just decreasing the overall total cycle time to machine these guys, which is going to equate to us being able to lower our prices on these guys there as well. So that's something that I am striving for, is to try to reduce the overall cost of these things. So now we're over onto the 1/4-inch end mill. That's the same one we use to interpolate all the holes. It's machining the counter bores in the bottom for the little rubber feet. These little 4 counter bores where we stick our little rubber feet. Those are made by 3M. We buy those from McMaster Car, and they work great. All right, this is one of my personal favorites right here. This is a 1/4-inch diameter ball mill, and we use the 3D deburr tool path in Fusion, and it deburrs. Let's go ahead and take the flood coolant off so you guys can see it, hopefully. I might have a little better video to show you, but I absolutely love that. It's one of my favorite things that I have learned and added to our CNC capabilities is just the deburr tool path. That's a Fusion add-on, and I'm so glad that we have it though. because it's removing every burr off every edge on these parts. We're running 10,000 RPM now, so that's running faster than what we ran that before on the TRM. So again, it just decreases the overall cycle time. It knocks off the edge off the 4 counter bores, gets the inside, gets the outside. Beautiful. All right, so now we're gonna swap over. This is our RV T-seat cutter. This is gonna cut those 4 little pockets on the inside of the leg, and then that'll wrap up the machining of these. We'll go ahead and show this. It makes the initial cut, and I've just got it set to a repeat pass to help clean up that finish on the inside. A lot of coolant. There it is. Into program. Door unlocks. We can open her up and inspect our work. This is where I put my earplugs in. Try to get the coolant blowed off. It's a bit of a mess. I usually do it like this, where I'll have this door and I kind of hide behind it like this. Kind of block some of the coolant from getting on me. Again, it's a messy thing to do, but we have to do it. So the last couple weeks we've been showing getting our Tool-X vises machined and ready to go, and you guys never saw it in production yet until this point. So this is where I was trying to get to this to show you how this has been working out for me. So once we get it all blowed off, I go ahead and loosen the vises. All right, and I'll carefully remove these 2 here, and we're gonna blow them off. I try to do that in the machine, and again, I put my earplugs in because that kills my ears. Just try to get as much of the coolant off as I can. And stack them out here on the cart. Now while I'm out here, I got a couple rags, and what I want to do is just wipe these soft jaws out, try to remove any chip that might be in there. If you have one chip in there and clamp it, it's going to mar your surface of the workpiece. All right, that's looking pretty good. I think they're all removed. And so now we can grab this guy here. And what I usually do is just blow it again. Make sure there's no chip in the hole that's going to drop down and sit on that face. And then gently set it in the pocket. I try not to scratch that side face. Push it against the outer jaws. All right, and now I usually just grab this rag and just kind of remove any of the chips that might be sitting here. This one isn't as critical because we're roughing out the top. And I got the stock sitting over here next to the mill. I'm going to come over here and grab 2 more blocks of aluminum. Wipe the bottom off with my shirt because I don't have a rag in my hand. Just make sure there's no chips on it from the saw. I forgot to mention that I did add the work stop over here on this side. Maybe we can throw that in the video so you guys can see what I did to add the work stop there. But once these pieces are in there, I push them against that corner and then tighten the vise up. I don't have any kind of torque spec to tighten it to, so I'm just using good old A-bomb torque until it feels like it's right. And I haven't had one pull out yet, so that feels about right. Come back over here to this vise and go ahead and tighten it up. This one gets tighter a lot faster since we're clamping on something more solid versus these Talon grips. So I just tighten it like that. It feels about right. I try to do it the same for every workpiece. And there we go. We now have our new work loaded up over here on the left side. These were finished, flipped upside down here on the right side. So my goal was to, every time we open the doors and reset, we're putting in new stock and we're removing 2 finished pieces. Now, with the exception of we're going to be coming back in here once the anodizing is finished, and we'll engrave the top and engrave the bottom. So probably going to utilize the other side of these jaws here. We'll flip those around, machine them just like we did this guy over here, so that when they come back, we can use one side. We'll use one side to engrave the top, and then we'll have this one, we'll be able to use the same setup there, and we'll engrave the bottom. And that shouldn't take very long to do that, but that's where we are. And then from here, we just hit cycle start and it's ready to cut again. But next thing I want to do before I hit cycle start is, you can see we've got a lot of chips built up in here. A lot of chips are building up and I don't want it to get away from me. So I'm going to go ahead and clean the mill out again and get rid of some of these chips. It does not take a long time for this chip pan to fill up with chips, and it gets away from you. But now we have our auger on this mill. But even that, I mean, it's very helpful, but you have to turn it on and let it evacuate some of the chips, and then kind of rake them down into these pockets again, and I'll show you what I mean, and then keep going with it. This is on the other side here, so like I said, just try to rake some of these chips down in here. And then turn the auger on. So to turn the auger on, you have to have the door shut, but you can just simply hit auger and then cycle start, and then that'll turn on. I can hear it, and it'll just start ejecting them out into this pan here. So after it gets about, say, that full, I just go ahead and turn the auger off. I've got to figure out the best way to do this. I don't actually have it running during production, so I'm going to play with that and see how it works. But you can see how the holes kind of empty out there, and so we have to take our brush and just rake them back down into those holes. And just keep doing that. Just keep brushing the chips down here. But I will say, it's much better than having to just scoop everything out of the, I mean, it's better than having to scoop them out of the mill. That's what I was trying to say. So, just trying to show you what we're having to do here. You don't have to get it completely clean. We're just trying to eliminate the buildup of a lot of these chips in the mill. Because what I have learned, what you don't want to do, which I have done on the TRM, is if you let this go and it builds up high enough, the chips, the rear way guard here on the back side, you know, this coolant pan tapers up towards the back. The chips will start piling up behind the mill, and when it's moving around, what it'll do, it ends up forcing some of these chips to go up underneath the chip guard, and then you start hearing that racket in there. These way guards have like rollers that roll on the frame, and it'll start rolling over those chips, making a bunch of noise, and it sounds bad. So I learned that on the TRM, and I'm trying to avoid that over here. So every so many parts, I usually take the spray nozzle and I'll spray in that back corner. I'm just going to go ahead and see if I can show you what we're talking about. You have to close the door in order to jog it. Jog the table forward. Those corners right there, if the chips build up too much right there, the movement of the machine will start forcing some of those chips to pack underneath that way guard, getting on the inside, which is what you don't want to do. So usually what I'll do, this is the point, you can turn flood coolant on and then take your nozzle, and I try to blow them off of that corner right there and get them down out of the way. So that's why you got to keep cleaning the machine out, so that you can make plenty of room for these chips during your production. Make a little bit more room. So I'll keep working at this off camera and getting all of our chips that are in here now pulled down to our conveyor or our screw auger and get them ejected out here. And I'm starting to run out of room. I've got some more room in those cans, but you can see they're starting to get pretty full. So I got the machine adequately cleaned out, ready to just start fresh again. So we're gonna close it up and keep running. Another modification that I meant to tell you earlier in the video that I just now remembered was we made a modification to our facing cut across the top of our drill index. By the way, this is one that we just pulled off a few minutes ago. I was gonna show you how pretty they look, you know, just cleaned up, just with soap and water. They really, really shine. This was the look that I was hoping that we could get with a clear anodizing on aluminum, but it just did not turn out this way. When you clear over the top of it, it actually kind of softens up the finish there, makes it a little bit more of a matte color, and that's why I decided to not do any more of the clear anodizing and go with the color. I just think the color looks so much better. But anyway, we made a mod to our facing path there. That's one of our new Ingersoll face mills. We went with a 2.5 inch diameter face mill, so it would just make one pass all the way across and be done. So in the program, once it pulls that face mill, it cuts this one and it cuts that, and it's done. It moves on to the mill in all the holes here. That particular mill, it's the die post finish from Ingersoll. It is designed specifically for leaving finish or making finish passes. So you can play with your feeds and speeds on that particular cutter. It's got a wiper insert that goes on there, so you can really dial it in and dial in a very, very beautiful smooth finish if that's what you're looking for on your workpiece. I think it's working well. We went from a 1-inch diameter end mill with aluminum rated inserts in there, making 3 passes across there, to that 1 tool path that goes across it. So we reduced the cycle time there, and I'm real happy with the finish that it is leaving on the top of our drill indexes there now. This is another project here that I've been working on this week, and what this is actually a test sample. In the event that the customer does want to go forward with making these, we give them a quote to make a few of these. And since I had a little extra time between running production on our parts there and our TRM was available, I went ahead and put the labor into it and tested this out. So I had Joe next door at the fab shop cut me a couple pieces of plate stock, 1.25 inches thick, burned it out, and I went ahead and set up in the lathe. We did our turning, and we did our boring, and we did our facing. And now the finished part, if we do these, we'll start out with the 1.5 inch thickness, because they want a specific thickness, which is going to be very close to 1.25 inches. So it needs to be faced on both sides to whatever that thickness is. So they're going to start with 1.5 inches. I just had Joe cut it out 1.25 inches because this can be close enough. So once we did that, I figured out how I want to chuck it and get the lathe work done. I created a very simple program to be able to drill the 4 holes. And what I used is to drill the 4 holes, we used our 16mm drill meister that's made by Tungaloy. And we drilled the 4 holes, and then I used a 1/2 inch diameter chip splitter end mill. This particular one's made by Helical, and we went ahead and just interpolated all 4 of those holes to the size that they want, which on their print is 0.79 inches. A little bit of an odd size. If I had to guess, it's a clearance hole for a 3/4 bolt that's going to go through there. They didn't say that, but that's just what I'm thinking there. So anyway, I went ahead and just proved it out. I got the lathe set up and got this done. I know how I want to turn and bore these now and then finish it as well. So the other thing that I wanted to make sure of is that the OD is turned to size, which is 7 inches without a bunch of marring and chuck marks on the outside. So what I decided to do whenever we were turning this is leave the OD a little bit big. You can pick whatever size you want. I just chose 30 thousandths. And then once this is taken out of the vise, I used our heavy duty Versa grip jaws to hold this. You know, it leaves a few little indentions, little marks on there. And this is a little bit from the flame cut or the plasma cut right there that didn't clean up. But anyway, you can go back in your 3-jaw chuck and just turn that OD nice and clean, and that's sort of like your final touch on that, you know, cleaning it up. So that's what I did, and we've got the machine, we got a program that's proven now, so if I get this job, I don't have to spend any time working on a program or even standing there using conversational. It's already in there, ready to go. And the vise is set up, and they told me there's, you know, it's highly likely that they're gonna have me go ahead and machine this. So just something else that we worked on today that I wanted to share with you as well. And you know, we got a little bit of video of doing all this machine work that we'll put in the video there as well.
All right, I just added the packing slip for our next drill index that's going out. We have 2 going out today.
Nice, those sold this morning, huh?
They did. I have personally packed up almost all of these.
I would say every single one.
I've touched every single one in one way or another, so, but this has been really fun for both of us. And I'm getting much better at it. Is this the way to use the tape dispenser? No, it is not. But that tape dispenser hates me, so I find it easier to do this. But just know how much effort goes into these. How much love goes into these.
Abby and myself and Keely as well, the 3 of us have touched every single drill index, every box, every packing, taping it up, putting the label on.
Yes.
It is just the 3 of us handling this. In fact, Keely, she's been coming over about once a week and spending the day with us, and she's really been enjoying it, helping us out. She helps Abby out.
Yep.
They hang out in the office, and she just helps her do things around here, and it's been great.
She has been a very hard worker.
Yeah.
But this one right here added a new state for us. So that is 30 states.
Really?
That we have sent an index to. 30 states and Canada.
This one here?
Mm-hmm.
So this one's Arizona. So we had not shipped to Arizona before that?
I don't think so.
Arizona. And this one right here is North Carolina.
Yes.
That's one of the things that we've actually really enjoyed, especially with the product launch, is that, you know, we had a lot of sales come through at one time.
Yes.
And it was really great. That first initial push, it was, I believe it was 28 states total that we shipped to, and one went to Canada.
Yes. Which the shipping has been a nightmare for international, but the Canadian one wasn't terrible. I think they ended up spending, you know, I'd have to look to know for sure, but thank you for doing it anyway, even though it was more expensive than it needed to be. Shipping is so weird now.
Shipping is just one of the struggles that we've struggled with trying to figure out, and Abby's doing her best to try to learn everything about this, and we hate that it's so costly to try to ship one of these overseas across the pond to Europe or any other country there.
Yep.
And we noticed that there was a lot of folks that backed out of buying one because it adds so much cost to it.
I don't blame them. I mean, it's adding $100 extra to get this out. It's just silly.
Yeah.
But we're trying to remedy that. We're trying to fix it, and I'll get to the bottom of it.
Yeah. Yeah, absolutely.
And maybe they'll be excited because there'll be a metric version.
We have that in the works. We have that in the works. We've had a lot of people ask about that, and we've had a lot of folks ask about different variations of this drill index. And believe me when I say that was one of the goals going into this, was that, you know, of course we have this design here that we're currently making, but I have other versions of this that I would like to make as well. But we have to get through the first one to see if we even have a product that people want to buy from us, right? So I think we have a good product. It seems to be doing well. And now
I loved the red.
Yeah, the red was really popular.
Yeah.
So, you know, I want to take this and expand on this, create a metric version and other versions as well. But it's one at a time. You see what it is. It's me, it's Abby, and Keely helps us as well. So we can only do so much, but that's where I'd prefer to keep this right now. I don't want to just grow so big that we've got a bunch of people around here. I want to keep it small and humble, and just keep working at it and learning what it is that we need to do to manufacture a part, package it up, and get it out to people.
We have learned a lot.
We have.
Well, I'm going to get these off.
All right, sounds good. It's just about time to go get a sandwich.
Yes, it is.
Yep, I'm ready. Well, guys, I think that's going to be about it for this video. As I mentioned earlier, it was going to be sort of a mixed format, but what I wanted to do was kind of bring you up to speed and show you the improvements that we made on our production, kind of show you the modifications, improvements we made using, you know, going to our VM mill over here, some updated cutters, updated feeds and speeds, and overall trying to learn how to reduce the overall cycle time on our products that we're creating. And I want that to, you know, pass right along to anything else that we decide to create and develop as well. You know and learn how to properly adjust your feeds and speeds for the cutters that you're using, and utilizing what the machine can handle to overall reduce the cycle times on the parts. So every day is a learning journey around here. We're always learning something. We make mistakes around here all the time, and we learn from those mistakes, and we try to improve and do better, and just we want to create a nice quality product for anyone out there that might be interested. We do want to give a big thanks to everyone that has continued to support us through both the channel, the social pages, and if you decided to buy a drill index from us as well. We love all you guys. We appreciate all the support that you give us, and we hope that you enjoy watching these videos and continue to come back watching these videos week after week. They're always going to be whatever jobs come in the shop, whatever customer jobs come in here that we're working on, whatever production we're going to be working on. And we still want to occasionally, whenever it makes sense to us, bring you some other stuff too, you know, like working on a tool or working on a restoration of some sort, you know. It's whatever it is that we get into from week to week, we like to try to capture a video of that and share it on the channel. You know, just share the journey of everything that's happened around here on and what keeps us busy. So thank you for tuning in. We hope everyone has had a great Thanksgiving holiday, and we're going to see you on the next video, all right? Love seeing that 10,000 RPM.